And I am back. What is up, everyone? Welcome back to the Hack Smarter Twist channel, or if you're watching this after the fact, welcome back to my YouTube channel. It has been a while, and for a few different reasons. I got COVID, and I'm actually still kind of sick. So, I had a cold, I think, for, I don't know, like 5 weeks, just a normal cold. I got over that for like a weekend, and then after that weekend, I got COVID, which was really fun. I got over COVID, then I went on vacation to Florida, and then when I was in Florida, I got sick with another cold right before I came back. So I am still stuffed up. I'm still sick, but I figured if I wait to start streaming again until I'm no longer sick, hey, I'm not going to be streaming until like 2024. So here I am. You'll just have to deal with my raspy voice. Hopefully I don't sneeze a bunch, and hopefully my nose doesn't start running, but we're going to do this anyways. We are going to hack stuff, sick or healthy. It does not matter. Let's do some hacking. If this is one of your first times here, sorry, my cat was on my lap. He just jumped off. Here's what to expect. It is 8 p.m. Well, not quite. I was going to start at 8 p.m. Central Time, but I was so excited to just dive back into this that we started 15 minutes early, and we are going to go until around midnight. If my voice allows me to go till midnight, we'll see how I do. But if we can go till midnight, that's the plan. We're just going to hack stuff for the next 4 hours. We're going to change it up a little bit. We'll do some TryHackMe. We'll do some AWS pen testing. Maybe we'll do some Hack the Box. But without any further ado, let's dive into it. I would encourage you, if you want to follow along, go ahead, boot up your VM. If you're watching this on YouTube, go ahead and pause the video. And once your VM is booted back up, start the video. And let's do this thing together and see what we can learn. Let me go and share my screen. Hopefully you guys can see my screen, and I should ask those of you watching on Twitch, everything sound good, everything look good. I'm going to take silence as yes, it sounds good. No one's yelling at me saying that the audio is not working, so I'll take that as a positive. What we are going to do to begin our hacking marathon is the dependency management room on TryHackMe. The reason I want to start this one is because it's created by my friend Amoeba Man, and Amoeba Man's probably going to join us, I'm sure. But right now, I believe it's like 3 in the morning, 4 in the morning where he lives. So whenever he wakes up for the day, I'm sure we'll see him jump into the chat. But we are going to begin our time working through his room. Now, in full disclosure, usually when I work through these rooms, I do them live, and it's like the first time I'm working through it. I did go through this room when it first came out. I think that was 2 or 3 weeks ago. So I went through it when it initially came out, but I cleared my progress. We're going to go through it again. And I'm sure I'll still stumble because it's been a while since I went through it, and a lot of the stuff was new to me, but really fascinating stuff, and actually answered a lot of the questions I had. I was messaging back and forth with Amoeba Man when I was initially working through this, and man, it's really excellent content to understand supply chain attacks in particular. So if you want to follow along, what I would encourage you to do is log in and TryHackMe, go to the dependency management room. I'm not sure if it's free. Only subscribers. So you do have to be a subscriber to TryHackMe. If you have not subbed to TryHackMe, would encourage you to do so. I think it's $90 a year, which is pretty affordable, and it is well worth the money. 1 second. Told you guys I'm still sick. We'll see how I do reading through all this. I got my cat's hair in my mouth too from when he was on my lap. What up, Cali Max? Good to see you as well, my friend. So let's go ahead and dig into this. The first thing that we need to do is get connected to the VPN. If you're new to TryHackMe or even Hack the Box, the way the connections work is you just connect via OpenVPN. So you can download your OpenVPN file from that platform. I believe mine is in the downloads folder. We'll sudo VPN. It's Tenebrae is my name on there. So if you're on TryHackMe, feel free to add me, and we will get connected to the VPN there. We'll just start a new one. Terminal. CD TryHackMe. Do I have a folder for this one? Oh no, this is just when I was doing the red team path. I was like, man, this looks messy. I finished the full red team pathway recently on TryHackMe. That's what all these files are from. So let's just make a new directory, and we will call it Dependency Management. Okay, there we go. And the other thing that we will do is we'll just pull this up, and we'll use this to kind of take notes of syntax and stuff as we go. And let's see what we can learn, shall we? Okay, let's dive into it. And once again, if you're new to the way I do these things, is a lot of people just skim this stuff. I think it's good to slow down and read it. I know that the creators of these rooms put a lot of time into explaining stuff and teaching stuff, and Amoeba Man in particular has an excellent gift of teaching. So let's slow down. Let's read through it together. Remember, our goal is not to rush through these things. Our goal is to slow down and see what we can learn. Man, I can't beat this cold, but let's see how we do. Introduction. It is very uncommon in modern times to find an application written completely from scratch. Whoops. Furthermore, writing it completely from scratch is probably a bad idea, since you will most likely introduce vulnerabilities by trying to reinvent the wheel. That would be especially true if I was the one writing the application. Instead, modern applications make extensive use of libraries and software development kits, or SDKs, that assist with the basic and sometimes complex features of the application, allowing the developer to focus purely on the key features and functionality of the application. These libraries and SDKs are called dependencies, since our application depends on them, right? Makes a lot of sense. While dependencies make our lives a lot easier, they have to be securely managed, since they now form part of the overall attack surface of the application. In this room, we will learn about security concepts associated with dependency management and show how a specific dependency management issue can be exploited by an attacker. Learning objectives. What are we going to learn? This room will teach you about the following concepts. Number 1, security principles of dependency management. Number 2, securing external and internal dependencies. And number 3, dependency confusion attacks. I am ready to learn about dependency management. Let's go. All right, what are dependencies? The scale of dependencies. While you may think that you are writing an incredible amount of code when you are developing an application, it pales in comparison to the amount of code that is actually performing actions for you and the various dependencies that you include. Let's take a look at a simple Python example. All right, so you can see we're specifying it's Python 3, import the OS dependency, import NumPy, and then we're doing some very basic math here. In this example, we are using the NumPy library to create 2 arrays and then multiply them with each other. We effectively wrote about 4 lines of code. However, just that first line right here executes initpy file in the background that contains 400 lines of code. Right there, 400 lines of code with an additional 30 imports. With a conservative estimate of 250 lines of code per import, this means that our 1 line of code has executed roughly 8,000 lines of dependency code. Yo, so isn't that crazy? I mean, just consider that for a moment. All the software that we have, all the scripts that we have, all the programs that we have, that is massive. So if you can attack the supply chain, imagine how many things you can affect as a result. And this has happened. If you just Google, you can read about it. I can't say that word. You are probably responsible for 0.01% of all code in your application, and dependencies make up the remaining 99.99% of the code. This is why dependency management is vital for the security of any pipeline or software development lifecycle process. Dependency management. Dependency management is the process of managing your dependencies through your SDLC process and DevOps pipeline. We perform dependency management for several reasons. Number 1, knowing what dependencies our application uses can allow us to support it better. We often want to version lock dependencies to improve the stability of our application, since newer versions may add new features and depreciate features that our application actively uses. Number 3, we can build golden images that already have all our dependencies installed, meaning we can perform faster deployment cycles. Number 4, when new developers are onboarded, we can help them set up their development machine by installing all the required dependencies. And finally, we can monitor the dependencies we use for security issues to ensure the dependencies are upgraded with the security fixes as needed. Most large organizations use tools for dependency management, such as JFrog Artifactory. This allows the organization to manage all of their dependencies from a central location and allows dependency management to be integrated into our DevOps pipeline. Build servers and agents can make requests to the dependency manager, so it's reaching out to be provided with dependencies when the application is being built or deployed. All right, what do we call the libraries and SDKs that are imported into our application? I'm going to go with dependencies. Boom. Internal versus external. While dependencies can be classified using various classifications, for this room we will focus primarily on one classification, namely the origin of the dependency. Hence, our dependencies can be classified as external or internal dependencies. External dependencies. An external dependency is one that has been developed and maintained outside of our organization. Usually these dependencies are publicly available. Some are free, but some can be paid for SDKs. Some examples of popular external dependencies include any Python pip package that you install from the Pypi public repositories, jQuery, and any other publicly available Node package manager libraries such as Vue.js or Node.js, and paid for SDKs such as Google's reCAPTCHA SDK that can be used to integrate CAPTCHAs into your application. External dependencies include almost any dependency that we ourselves have not created. This means that someone outside our org is responsible for maintaining the dependency. Makes sense? Makes sense. The biggest thing, though, is even if they are responsible for maintaining it, right, you still got to make sure your dependencies are up to date, which many organizations miss this. Internal dependencies. An internal dependency is one that has been developed by someone in our organization. These dependencies are usually only used by applications that we develop internally in our organization. Some examples of internal dependencies include, number one, an authentication library that standardizes the authentication process of all our internally developed applications. Number two, a data source connection library that provides applications with various techniques to connect to different data sources. And number three, a message translation library that can convert application messages from a specific format to one that a different internal application can read. Glancing back at the chat, Callie Max said, glad to see you. Get well soon. I think I read that. Thank you. He said, it's a very good room. Nate said, wow, that's a lot. And Jack Neely said, it's a really good write-up. Just wait till we get to the practical part. This is the theory, but we have two really good hands-on exercises we're going to do that helps tie this together. So hang with us. If you think this is good, just wait till we get to the hands-on part of it. Internal dependencies are usually created to standardize an internal process and ensure that we don't have to reinvent the wheel every time we want that same feature in another application. Since we develop these dependencies ourselves, we as an organization are responsible for maintaining these dependencies. Careless Stopper said, hey, I want to offer promotion of your channel. You're a scrub, bro. I don't need your promotion. Let's keep going. External versus internal. The origin of the dependency does not necessarily make it better or more secure. However, based on the origin of the dependency, the attack surface is different, meaning we will need to take different security measures to protect each. In this room, we will talk about the security measures for both external and internal dependencies before practically exploiting one of the security concerns internal dependencies have. And Nate just pulled out the ban hammer and banned the spammer. Thank you, sir. All right. Would an authentication library that we created be considered internal or external? Well, remember, if it's something we created for our apps, that would be internal. Would jQuery be considered an internal or external dependency? Well, that would be external, of course. There we go. All right, so if you haven't already launched this next machine, go ahead and do it. It takes a little bit to start up. I launched it actually before I went live, so I already have my IP, but this is going to be the first machine that we get to do some hands-on stuff with an S3 bucket, if my memory serves me correct. I'm not sure if I remember correctly, though. But as mentioned before, external dependencies are ones that are hosted, managed, and updated by external parties. External dependencies are an interesting part of the SLDC, or software life development cycle. I may have totally butchered that. To secure, since we are not directly responsible for the security of the dependency. Still, if we want a secure application, we will have to manage these dependencies. In this task, let's take a look at some of the security concerns with external dependencies before executing a supply chain attack. Public CVEs. The team that develops external dependencies are not robots who don't make mistakes. They are humans just like the rest of us. This means that there may be vulnerabilities in the code that they have written. The issue, however, is that these vulnerabilities will be publicly disclosed, usually as a common vulnerabilities and exposure, or CVE, once the developers have created a patch. While this is good practice to ensure that developers create patches, for us, it is a problem since it means that our specific version of their dependency is now vulnerable to an issue that is advertised to attackers online. I saw a great meme about this where it was like, security researchers celebrating because they found a CVE, and like the blue team crying because now they have to patch a bunch of stuff. I haven't found any CVEs, but I'm now on the red team side of it, but I was on the blue team side, and I was responsible for patch management. So I know how frustrating it can be when a new CVE comes out and everyone's excited about it, but it's up to you to go patch your stuff. As such, we must react as soon as possible and patch our dependency. But this is easier said than done. We may have version locked dependency for the stability of our application. So, upgrading to a new version means we will first have to determine whether such an upgrade could cause instability. All right, this is really important, and I want to emphasize this for those of you who want to get into pen testing or the red team world. When you're a pen tester, it's really easy when you're looking at an application, you see some vulnerable package, you're like, hey, like, why don't they just update their stuff? It's so easy to update. But the truth is there's a lot more to updating even a package or a dependency. It could break something else, right? So you really have to strongly consider business requirements and security requirements and balance them properly. If you're a pen tester, it's good to be able to offer grace when you're speaking to a client, when you're explaining something to them, but also recognizing businesses are big, bureaucracy is big, it's a real thing, and it's not always as easy to patch something as it seems right away. I can say that from being the one who had to patch stuff. The problem gets even worse when you start to talk about dependencies of dependencies. It is perhaps not the SDK that you are using that is vulnerable, but a dependency of the SDK. That is, since that dependency has to be updated, we will also need to update our SDK. Log4j, is it Log4j or Log4j? I've always called it Log4j, but I know some of you weirdos call it Log4j, so let me know if I'm saying it wrong. Log4j is a prime example of how bad this can truly get. Log4j is a Java-based logging utility. It was used in almost every application that was developed in Java. This led to several products becoming vulnerable when a vulnerability was discovered in the dependency. I'm sure you're all aware of that. You can look here for the full list of impacted products. Let's glance at that. The list got so big, more than 1,000 products, that they had to sort it alphabetically. Let's see, is it just in one of these software lists? Oh, wow. So these are just the A's, right? And you saw the alphabet there. So Log4j, massive, massive stuff. Once again, once those, like the pen testers were excited about it, but if you were on the blue team, which I was at that time, you were not excited about Log4j. Depending on the discovered vulnerability, it will impact the risk associated with the specific dependency. Since Log4j's vulnerability allowed for remote code execution, the impact was significant. If you would like to explore this issue more, have a look at this room. I think this is a room created by none other than John Hammond, maybe? Let's see if I'm right. You can see I did the room. Yep, John Hammond, that's what I thought. Excellent room. So if you want to learn more about Log4j, work your way through this room. John does a really excellent job of explaining it, and you can do hands-on both exploiting it as well as learning how to detect, mitigate, and patch it. So really, really good stuff. Shout out to John Hammond. I know he's probably definitely watching this right now, so thank you, John, for that. Supply chain attacks. Even if dependencies do not have any vulnerabilities and are kept up to date, they can still be leveraged to attack systems and services. As more and more organizations are becoming security conscious and making it harder for an attacker to compromise them, attackers had to become more crafty. Instead of trying to attack the application directly, which has been hardened, an attacker instead targets one of the dependencies of the application, which may have been created by a smaller team that does not have such a large security budget. These indirect attack methods are called supply chain attacks. One advanced persistent threat group, APT, namely the MageCart group, was notorious for performing these types of attacks. Some highlights of their actions. They compromised the payment portal, a British Airways online portal, led to the compromise of credit cards of customers and a fine of $230 million, compromised more than, 100,000 customers' credit cards by embedding skimmers in various payment portals of various applications, and compromising more than 10,000 AWS S3 buckets and embedding malware in any JavaScript found in those buckets. Crazy stuff. The MageCart group showed us that you do not really have to target an application directly. It is far more lucrative to compromise a dependency used by the application. These supply chain attacks are even more effective since a dependency might be used by several applications, meaning the compromise of a single dependency can lead to the compromise of several applications. There are several ways to compromise dependencies, but by far the most common is when dependencies are insecurely hosted, allowing an attacker to alter the dependency. This could be, for example, an S3 bucket that has world writable permissions configured. An attacker could abuse these permissions to overwrite the hosted dependency with malicious code. All right, so you may not know what an S3 bucket is, and you know who can explain this better than me? Hold up. So S3 bucket is through Amazon. What I don't like about AWS is they use just weird terminology for their stuff. It's kind of like FTP is how I think of it, where you can host different things. So a lot of websites will host images and stuff in an S3 bucket, but only the image is available. When an S3 bucket is world writable, that means you can embed anything in it that can then attack the website, which is what we're going to do. But let's go like this. Let's pull up ChatGPT. ChatGPT is an awesome tool, and say, hey, our robot friend, how can I assist you today? Can you explain Amazon S3 buckets like I am 5? Sure. So imagine you have a toy box and you have a lot of toys to put in it. You can't fit all the toys in one box, so you get more boxes to store your toys. Amazon S3 is like your toy box, but much bigger and can hold a lot more things. Instead of toys, it can store all kinds of digital stuff like pictures, videos, music, and documents. But because it's so big, sometimes you might forget where you put something, or you might want to share something with your friend. That's where the bucket part comes in. Each bucket is like a label or a tag that you can put on your stuff to help you find it later or to share it with other people. So when you upload something to Amazon S3, you can put it in a specific bucket, and then you can easily find it later or share with others by giving them the name of the bucket. And now let's ask, what would happen if my S3 bucket was world writable? So if your S3 bucket was world writable, it would mean that anyone on the internet could write to or modify the contents of your bucket without any authentication or authorization. So you think of like FTP. So if you've done pen testing, FTP is a common, well, not pen testing, CTFs. FTP is a common port that you're attacking. One of the first things you check when FTP is open is, do you have anonymous access? And if you have anonymous access, can you write to the FTP server? And sometimes, at least in a CTF, the FTP server is hosting a file that's actually on the web root, and then you can upload a reverse shell to the FTP server, execute it on the web shell, and you got code execution by abusing an FTP server that's writable. S3 buckets is a very similar concept. Here are the consequences: data breaches, data loss, misuse, right? So to avoid these risks, it's important to ensure that your S3 bucket is properly secure with appropriate access controls and permission, and is only accessible to authorized users or services. HunterBot said Grey Hat Warfare has a good tool to view open S3 buckets. You see a bunch of stuff like Etsy password files. It's nuts. Yes, we at Rhino, I believe we actually use that. I haven't done AWS pen testing myself, but we, I believe, are subscribed to that tool. So yeah, cool tool. Haven't used it myself, but I've heard good things about it. All right. Back to this room. Hopefully, if you're new to S3 buckets, you understand what they are. If you create a free AWS account, you can experiment with those. And actually, I have done some videos on AWS pen testing. You can catch them on my YouTube page. And if time and my voice permits us, with this cold, I might do a Cloud Goat scenario when we're done with this, and we'll do some AWS pen testing. Okay. Exploiting supply chain attacks. Let's try to perform a supply chain attack. We will simulate a supply chain attack. Start the attached machine, which we did, and navigate to there. So let's go ahead and do that on the attack box. Now, when I initially did this room on my own machine, there was actually an issue with doing it in your own VM, and I had to switch over to the attack box. I believe that issue's fixed, but worst case scenario, we will switch over to it. I don't know why it's continually late. Oh, it's continually loading because I haven't. So what it's trying to do right now, the reason it's loading, is trying to pull a script from the S3 bucket. But because we are simulating S3 bucket, we have to throw it in our Etsy host file, which I bet is what we're going to do next. You will see this is a simple authentication portal. Before we can continue, we need to embed a hostname entry to simulate the internet-facing S3 bucket. Perform the following command on your attack machine to inject blah, 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 blah. I might already have this with a different IP, so if it doesn't work at first, I might just have to check that out. Let's just go like that. Should work. All right. Was that seeded? Oh, I need to delete the other one real quick. We'll just do Pluma and we'll do Etsy hosts. Oh, I need to do sudo. And we'll just delete this first one. We don't need that one. This is when I first was working through this. Let's save that. Go back to here. Let's refresh this and it should actually load properly now. Maybe. Come on, I believe in you. Wonder if I have to close it out. It's trying to connect to this. Let's see if we can connect to it. So we'll copy link. Oh yeah, so we can connect to it. We'll give it a second. There we go. Now it loaded that dependency. So that's the script that is loading, of course, from that S3 bucket. Okay, once initiated, you can refresh the web page and you should see the dependency loading. If you inspect the code of the application, you will see that it pulls a dependency from CD and TryHackMe. Let's inspect this dependency a little bit more. Open a link to that dependency and it should allow you to download a JavaScript library. So I know I did that fast for testing, but let me do it a little bit slower. So we can see if we look at the page source, we see this authentication, right? So hello there, please authenticate to this website. So there's the text for that, and it's asking us for our username and our password, and it's submitting it through this auth.js is what is being used, which is coming from our simulated S3 bucket. So this is our pretend S3 bucket right here. And if we go ahead and just open that, it should download it. Or we can see it right here. So this is our shared authentication library. It includes a really cool function that will auto-submit the form when a user presses enter in the password text box. And I just want to point out, this is super realistic. So even if you go to any other page and you look at the source code, you're often going to see S3 buckets being used to host scripts, images, videos, things like that. So once again, if you could compromise an S3 bucket, you could take over that website by replacing one of those scripts with a malicious script. So we're setting a variable called input, and we're getting our text password, we have event listener, a key press, function event, etc., etc. So very basic authentication, log in with username and password type stuff. Make sense? Makes sense. Taking a closer look at the code in this library, it seems to add a JavaScript event that will monitor the password text box for keystrokes and automatically submit the login form if a user presses enter. With no real vulnerability in the code, let's take a look at where the dependency is being hosted. If we take one step in the if we go back one step in the request, you can see that this seems to be an S3 bucket hosting the dependency, right? So let's just go one step back. There you go. So often when you go to an S3 bucket, it'll say access denied. But you can see we have this pretend S3 bucket right here. This is what it actually looks like. We have our libraries, we have our auth.js, blah, 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 blah. And we can see some information here, which we shouldn't have access to. We're able to list it, and we shouldn't be able to list at least this libraries directory right here. A simple way to see if the team perhaps misconfigured the S3 bucket to grant world writable permissions would be to try a simple put request. Now, I always am a fan of typing stuff. Can I do it this way? Yeah, I can. Right? Even though we can copy and paste it, it's better, in my opinion, to type it and make mistakes as you go. So we're going to type everything out as we learn together. So we're setting a curl request, put request, and we're going to go to that cdn tryhackme.loc port 9444 libraries test.js -d. I believe that stands for like the data that we want to send. So what we're doing here is we're uploading a file called test.js. We're seeing, can we modify this? Very similar when you're doing a CTF and FTP port is open and you try to put a file there. We're doing a very similar thing but to an S3 bucket. And here's the data we want to put in there. Testing world writable permissions, like that. I'll do V for verbose mode. Okay, so we connected there, and it seems like everything worked. Now, if we go back to our library here, let's refresh this. Well, let's just even go to test.js. Cat's scaring me, bro. I don't know what he's doing. He was just making a weird noise next to me. So there you go. We were able to upload this file, test.js, testing world writable permissions. I don't know why I'm doing view source. This is like that. And it would download it that way. If we go back one, we should be able to see it here. Yeah, we can. So you can see we're able to list the files. We have the auth.js and we have the test.js. Clear as mud? All right, cool. This is looking positive for a supply chain attack. Looking positive if you're a hacker, not looking positive if you're the organization. At this point, there are several different ways we could go about exploiting this world writable S3 bucket to cause a supply chain attack, but we will keep it simple by embedding a credentials skimmer that will send us a user's creds when they click submit. So download the auth.js dependency and modify the code to look like this, which I think we did. If I go copy home tire downloads auth.js to here. Yep, that looks like the right one. We'll just open in Pluma because I like Pluma. And we'll throw this over to the side like that. So we're going to modify our code. Let's see what modifications we are going to do. So var input, document get element ID. That's all staying the same. Input, add event listener, key press, function event, if event key equals enter, event prevent default. And now it looks like we are adding a try statement. So let's give that a shot. And we'll see if we can understand some of what's going on here. So we have this, we're sending the HTTP request. It would appear we're setting a variable. I wish it would go straight to that line, a variable for the user, which I need to make this big to see exactly how the formatting is. Okay, let's just read through this first. So we are setting a variable here, the HTTP request. Then we're setting a new variable called user, and we're going to store the username that's entered into that variable of user. So when the user enters their username, it's going to be stored in this variable. And then we're setting another variable called pass. When the user enters their password, we're storing the value of their password in our pass variable. And then what it's going to do is it's sending a GET request, THMIP, item, user. Oh, so what we are doing is we're exfiltrating the data via HTTP. So when the user enters in their username and password, what it's actually going to do is send the user parameter to our machine. We're going to host an HTTP listener, so it's going to send the user parameter to our machine. So I'll have the username, and then it's going to send the password as well to our machine. So we're probably just going to set up a simple Python web server to listen, and then when a user types in their username and password, it's going to send over their information. I believe this sleep timer is what Amoeba Man needed to add to make it work on a VM. It always worked on the attack box, but he had to add this to make it work on the VM. I don't remember the technical reason behind that. I'd have to look at my Discord messages. But we see what's going on here. Yeah, let's go ahead and see if we can type it. Otherwise, I might just copy and paste that just because I hate typing the code when it's this small. Can you guys hear my cat? He wants to be on that. He's the next streamer for the Hack Smarter Twitch channel. When I can no longer talk because of my throat, you guys get to listen to my cat talk to you guys about hacking. He also wears all black. He has black fur, so he would fit in well as a hacker. Okay, chill out, cat, bro. We hacking. Okay, variable user. Document. Gosh, he's loud. Get element by ID. It's cracking me up, dude. It's super loud. Text username. And then we want the value of that. So I think I typed that all right. Once again, we're setting a variable called user. And when the user types in their username, it's going to store it in that variable. That's why we're doing a try statement here. And we'll do our variable pass. Very similar as the other one. Get element by ID, text password like that, value like that. And then our variable we set up here, right? We're going to open using that request. So we set up the HTTP request there, and now we're going to send it over to ourselves. orec.open get HTTP and then our THMIP 10.13.4.234. Of course, if you're following along, you have to use your own IP. Don't use mine. It will not work for you. The item we're going to send is, of course, the user parameter, and we'll set that right there. And then we also want to send the password. If you guys see a typo as I type, call me out on it. Otherwise, I'll realize my mistake when it doesn't work. Pass like that. There we go. And now, if we go back over here, close our try statement like that. And we're going to have a catch. So try and catch. So if there's an error, we're going to catch the error, and we're going to print it out to console. I wonder if this was just for troubleshooting, so that when the error happened, he could troubleshoot what the error was by looking at the console. I'm not sure if it's needed. I think this is just the troubleshooting part of it. And because it is, I'm going to go like this. I'm going to cheat and just copy the rest of this like this. So underneath that, wonder if this will do it properly. Whoops. If I paste, there we go. Cyber Canada says it's a typo. Text password versus text password are both accepted. Oh, yeah, no, it is a typo. Good call, dude. Thank you. Save me some time there. Once again, you could easily copy and paste this, but I think it's good to type it out, at least for the most part, and even make mistakes as you do it. Let's look at our code, and let's just review it to see if it looks correct. So here was what was already there. Right, that's a standard thing. And what we're doing is we're essentially keylogging it with our try statement here. So we're sending a new variable right here. We're making HTTP request. We want to store these variables. Well, we want to send these variables via that HTTP request. So we're setting a new variable called user. And the user is going to be the text username when the user enters their username. And then the password is going to be the text password when the user enters their password. And then we're going to send that information. We're going to set up a Python listener, and we're going to send the user variable and the password variable to us. And then hopefully we have the username and password of the user. Sound good? Sound good. Okay, I'm going to make this big again. When I did this, I had 2 screens, but now I just got one for you guys. I think everything's good. If you guys see something I missed, please let me know. Code explained. Make sure to modify THMIP to be the IP of your TryHackMe VPN or the attack box IP, since we want callbacks to occur to this host. The injection is fairly simple. Once the user presses enter to submit their creds, we make an XHR, an XML HTTP request to our host, where the username and password of the target are embedded as parameters in the request. You will notice some lines of code for the creation of a sleep function, and then using said sleep function before the button is clicked. This is to ensure that the malicious XHR request is completed before the page transition occurs. Otherwise, a modern browser would stop the request from occurring. That's the issue I had. I think I was one of the first people to actually go through this room, and I pinged Amoeba Man about it, and he quickly troubleshooted it and figured out what's going on. All right. Let's overwrite the existing auth.js file with our embedded skimmer. So let's go ahead and save this. And I think it should be saved here. Yep. I think that looks good to me. So we are going to do a very similar thing to what we did before, where we send a curl request, but we're going to replace the other auth.js file with our own auth.js file. So curl cdn.tryhackme.loc for local 944 libraries auth.js. So we're targeting that since we have world writable permissions file, and we're going to replace it with our file, the auth.js. Okay. Perfect. And now I'm just going to open a new tab. We'll do sudo python3.m. I don't need to do sudo because I was thinking port 80. So Python 3, and we're just going to host a very simple Python web server there. And we can test if our skimmer is working by using the website ourselves. Complete the form and press enter after typing in your password, and you should get the credits. Now, this is where it didn't work for me on my own VM. If it doesn't work, we can check our code. We'll do hack smarter and password 1234 because that's my real password I use for everything. No. I probably did something wrong. So a few things that we can check. Let's first view page source, and let's see what file is here. So you can see it did not upload our file. Now, a few things that we can check. I know this is going to be weird. I had to go look. Actually, it worked. It's a caching issue. So if I open a new private window and do it here, it will probably work. It's just caching the old script on my browser since it already loaded it. Maybe. Weird that it's not working for me, but it is actually working for the flag. So what's going on here is every minute there is a robot that is to act like a user attempting to log in. And you can see we stole that robot or that person's credentials. Their user superpass, their pass is super secret password 12345 @. For some reason, it's not working when we do it. And once again, I think it's probably just some weird thing with what is being cached. I'm going to glance at it again. Let's see our script. Okay, so you can see our script's updated here in the new one, so it should be sending it over. I mean, it sent over that user. I don't know why it's not sending over this one. Gosh. Submit query. Weird. Let's see. Nate said also, I'm not sure if this works on imported scripts, but if the input box, quiet cat, in HTML have IDs, you should be able to reference with ID value instead of document get. Your message got cut up, but yeah, I think I see what you're saying. Not trying to give help, but it blew my mind when I learned that. So Sharon, yeah, I think I remember you talking about this. You learned this on PortSwigger, right? I remember you sharing about that. Okay, well, it worked. Since we got the creds of the actual user, we're supposed to be monitoring. Don't know why it's not working for us, but clearly it's actually working. We host the entire Python server. See, we're getting it again. I think every minute it sends it over, or every 5 minutes, one of the two. We can test if our skimmer is working by using the website. Didn't work for us, but we did steal legit credentials. If this works, we now just need to wait for someone to authenticate. Give it 5 minutes, and you should intercept credentials from an actual user, which we did. Once you've intercepted the user's creds, use them to authenticate to the website and discover the flag. All right, here's where I had to do incognito mode, or private window, or whatever browser you have, in order to get the flag. Before, it would allow me to log in, but it wouldn't give me the flag. And this was my fix. So if you have this issue, this is how I fixed it. So we have super user and super secret password right there. There we go. There is our flag. Let's go back to here. We'll pull this up. We'll drop our flag here. We'll finish reading that too, but we'll just get this stuff dropped in here. Okay. First challenge done. All right, defenses. It is difficult to defend against the attack stage against external dependencies since there are so many and new vulnerabilities are found daily. However, there are certain things that we can do to limit the risk. Number one, make sure to update and patch dependencies on a regular basis. This would include emergency patching of dependencies if a sufficiently serious vulnerability was discovered, log4j. Dependencies can sometimes be copied and hosted internally. This will reduce the attack surface. And 3, subservice integrity can be used to prevent tampered JS libraries from loading. In the HTML include, the hash of the JS library can be added. Modern web browsers will verify that hash of the JS library, and if it does not match, the library will not be loaded. Okay, what advanced persistent threat group is notorious for the supply chain attack? It was that one group, y'all. MageCart. It's a cool name. One second. Need to get tissue. All right, let's keep going. Securing internal dependencies. Internal dependencies are any libraries or SDKs that we have developed internally in our organization. As such, we are responsible for all aspects of the security of the dependency and its management. As mentioned before, the primary reason for creating internal dependencies is to ensure that we don't have to reinvent the wheel every time we develop an application. Internal dependencies allow us to standardize certain processes such as authentication, registration, and communication. Security concerns. Internal dependencies have similar security concerns as external dependencies. Although internal dependencies allow us to standardize a process, if the dependency has a vulnerability, it will affect several different applications in the organization. We therefore have to perform security testing of our dependencies before they are released for use. Another issue is that internal dependencies can become legacy code incredibly fast. The developer that created and maintained a dependency has started work elsewhere, meaning the dependency no longer receives updates. If such a dependency is used in several applications, it can become an issue if a vulnerability is discovered. The problem can only be made worse if the documentation is not kept up to date, allowing someone new to take responsibility for the dependency. Very real-world problem. A unique security concern to internal dependencies is storage. We want to ensure that a dependency can be accessed by all developers for use, but not modification. If all developers can simply modify the dependency, an attacker would simply have to compromise a single developer to compromise several applications. Hence, we need to protect write access to dependencies. In some organizations, even read access is restricted to reduce the attack surface further. So tools. Applications and tools must be used to manage internal dependencies effectively. These tools would differ based on our needs. If we develop code only in a single language such as Python, we could simply host an internal Pypi repository server. This would allow us to upload and install packages similar to how it is performed using pip and the internet-facing Pypi repository. 1 second. We're going to pause here. I'm going to go ahead and start this next machine so it has time to load. And then we'll go finish this. However, if we develop applications in different languages, we may opt to use the dependency manager such as JFrog Artifactory. JFrog allows dependencies to be centrally managed and integrated into the DevOps pipeline. As developers are writing code, they can make use of the various dependencies hosted in Artifactory. Artifactory also has the ability to manage external dependencies that are used internally as well. It provides a single source for all dependencies. While such tools are great to help us manage dependencies internally, if they are compromised, it would lead to a significant impact. One such attack that can be formed against dependency managers is dependency confusion, which will be discussed in more detail in the next task. All right. What do we call a dependency that we have created ourselves and are responsible for maintaining? Annoying. Oh, not the right answer. All right, never mind. Internal dependency. Theory of dependency confusion. Dependency confusion is a vulnerability that can exist if our organization uses internal dependencies that are managed through a dependency manager. In short, a race condition can be created by an attacker that can lead to a malicious dependency being used instead of the internal one. Okay, let's pause right here because some of you might be like, what's a race condition? Well, you know who can explain those better than me? Our robot friend. Explain like I'm 5, a race condition in cybersecurity. A race condition is like a game where two players try to get to the same spot at the same time. In cybersecurity, it happens when two programs or processes try to access or modify the same data at the same time. Imagine you got two robots, Robot A and Robot B, who need to make a sandwich. They both reach for the same jar of peanut butter at the same time. Robot A gets there a split second before Robot B, but Robot B doesn't realize and tries to grab the jar too. This causes them to bump into each other and spill the peanut butter all over the counter. In cybersecurity, this can happen when two programs try to modify the same file or data at the same time. For example, imagine two users are trying to edit the same document at the same time. If they both try to save their changes at the same time, the system may not know which changes to keep and which to discard. This can result in the loss of data or corruption of the file. To avoid race conditions, developers use techniques like locks or that to ensure that what program can access or modify a piece of data at a time. This way, the programs take turns and don't bump into each other like Robot A and Robot B did with the peanut butter. Very cool. Tyler Ramsbey fan said, "Hello, Tyler. Hope your sickness is getting better." It kind of is, dude, but I'm all stuffed up. It is really hard to talk continually when you have a cold. I feel fine, but I sound worse than I really am. But we'll see how far I can go through this. Most Wednesdays I will go till legit midnight, but it's tough to do all this talking with a cold. But I want to at least finish this and maybe do a cloud goat scenario afterwards, depending on how my voice is doing. Okay. Background: dependency confusion was discovered by Alex Bierson in 2021. The issue stems from how internal dependencies are managed. Let's take a look at a simple example in Python. So pip install numpy. What actually happens in the background when we run this command? Well, when we run this command, pip will connect to the external Pypi repository to look for a package called numpy, find the latest version, and install it. In the past, there have been some interesting ways this package should be compromised through a supply chain attack. Typo squatting. An attacker hosts a package called numpy, hoping the developer will mistype the name and install the malicious package, which if you've ever installed packages, it's very easy to make typos. So pip install numpy, you make a typo, you just installed a malicious package that now has access to your computer. Source injection. An attacker contributes to the package for a new feature through a pull request, but also embeds a vulnerability in the code that could be used to compromise applications that make use of the package. And domain expiry. Sometimes the developers of packages may forget to renew the domain where their email is being hosted. If this happens, an attacker can buy the expired domain, allowing them full control over email, which could be used to reset the password of a package maintainer to gain full control over the package. This is a common risk for legacy packages on these external repositories. Fascinating stuff. There are several other supply chain attack methods, but all of them target the dependency or its maintainers directly. If we want to use pip to install an internal package and we follow the example on Stack Overflow, like all good developers do, our build step would look like this: pip install numpy extra index URL and then our internal Pypi server. The extra index URL argument tells pip that an additional Pypi server should be inspected for the package. But what if numpy exists in both the internal repo and the external public-facing repo, right? So here's robot A, robot B, the internal one, external one, and they're fighting, right? Which one's going to win? This is the race condition. How does pip know which package to install? Well, it's simple. It will collect the package from all available repos, compare the version numbers, and then install the package with the highest version number. You should start to see the problem here. So let's just stop. I want to give you a second. What do you think the problem is? Get in your head. How would you abuse this? It installs one with the highest version number, right? So common sense says, well, if you're doing a malicious package, give it a version number of like 9999, right? So it has the highest version number. Staging a dependency confusion attack. All an attacker really needs to stage an internal dependency attack is the name of one of your internal dependencies. While this might seem like a challenge, it happens more frequently than you would expect. Developers often ask questions on public forums such as Stack Overflow, but do not obfuscate sensitive information such as the names of libraries being used, some of which could be internal dependencies. Some compiled applications like Node.js will often disclose internal package names in their package.json file, which is usually exposed in the application itself. Once an attacker learns the name of an internal dependency, they can attempt to host a package with a similar name on one of the external package repos, but with a higher version number. That's the race condition. This will force any system that attempts to build the application and install the dependency to get confused between the internal and external package. And if the external one is chosen, the attacker's dependency confusion attack will succeed. The full attack is shown in the diagram below. All right. So the attacker learns name of internal package. All right. They upload a higher version of the package to a public dependency manager. Build server pulls package from external repo right there. And the build server pulls package from internal repo. So when the build agent is requesting it, it's pulling both packages and it's comparing them which one is higher. Attacker's version is higher, thus it's sent to build agents. Malicious code is introduced into the code pipeline, and we have pwned them. Considerations. There are a couple of things that should be kept in mind. Since we only know the name of the internal package, not the actual source code of the package, if we perform a dependency confusion attack, the build process of the pipeline will most likely fail at a later step since the actual package was not installed. Number 2, our external version number must be higher than the version number of the internal package for the confusion to work in our favor. However, this is easy since we can simply have a package with the version number 9000, since most packages have major version numbers lower than 10, And dependency confusion can affect any type of package, such as Python pip packages, JavaScript npm packages, or Ruby gems packages. We will demonstrate the attack through Python for simplicity. Let's look at practically performing dependency confusion attack in the next task. Let's do it. What is the name of a common supply chain attack that relies on users mistyping the names of packages that they wish to install? Typo squatting, I believe. Dependency confusion relies on the race condition of what of a package? Version? All right. Okay. Terminate the machine from task 4. We did that. Blah, 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 blah. We will have to simulate the external Pypi package repository, since uploading malicious packages is against Pypi's terms of service. Come on, be a man. To ensure that you can access this repo and the application, use the following command and add an entry to your etc host file. I think I did this on the attack machine, so it shouldn't be in our terminal. We can close this now. There it is, external. I don't have any other ones, so we should be good on there. Environment explained. The machine simulates a build environment that has the following: an internal dependency manager, which is Pypi, and a build server, Docker Compose. The build environment will rebuild an API application every 5 minutes. Once you have given the machine a couple of minutes to start, you can verify that the API is working by running this command. So for this time, I will just copy it, and it's just a curl command. And it is, right? So it's returning us an array of numbers, it would appear. You see the API response to the data set. If you don't get a response, wait another 5 minutes and try again. Dependency disclosure. The developer of the application has posted a question on a public forum. Bad. Upload package to internal Pypi server. Hi, y'all. How would I upload a pip package to our internal Pypi server? I know I would use the following to upload externally, but what should I change? Twine, upload, dis, data, db, connect. Ooh. Is there a flag or something I can add? In the post, the developer seems to have disclosed the name of the internal connection, right? You guys see that? Right there. We see the version number as well. This is all we need to get started on our dependency confusion attack. Remote code execution in the installation step. To stage a dependency confusion attack, we will need to develop and build a malicious package that will execute code once installed. Since we only know the name of the package and don't have access to the source code, the application will most likely fail once it tries to run our package. So our safest bet is just to get RCE earlier in the process. Hence, we want remote code execution once the package installation completes. This is probably a good place to explain how pip packages are built from Python code. If you want to explore the process in more depth, have a look at tutorials like this. Let's do this. ChatGPT is taking a second. When you install a Python package using pip, the following happens. The pip command is executed in the terminal or command prompt with the package name and version you want to install. Pip searches for the package on the Python package index, Pypi, or other specified package repositories. Once pip finds a package, it downloads the package source code or precompiled binary file to your local machine. Pip then runs the package's setup script, usually setup.py, which contains instructions on how to install the package. The setup script may include commands to compile and link any necessary C or C++ code, or to install any required dependencies. The package is then installed to your Python environment, either globally or within a virtual environment, depending on how your Python environment is configured. When you import a package in your Python code, Python searches for the package in your Python environment site packages directory, where pip installs packages by default. If the package is found, its modules are loaded into memory and you can use them in your code. If you need to uninstall a package, you can use the pip uninstall command, which will remove the package file from that. Okay, so makes sense? Makes sense to me. Thank you, almighty ChatGPT. Appreciate it, my friend. The most basic pip package requires the following structure. We have our package name, and then within that, we have init.py, main.py, setup.py, which is what it was talking about. Package name, this is the name of the package that we are creating. In our case, it will be data db connect. Init, or initialization. Each pip package requires an init file that tells Python that there are files here that should be included in the build. In our case, we will keep this empty. Main.py, the main file that will execute when a package is used. We will create a very simple main file. And setup.py, this is the file that contains the build and installation instructions. When developing pip packages, you can use setup.py, setup.cfg, pyproject.toml. However, since our goal is remote code execution, setup.py will be used since it's the simplest for this goal. Recreate this file structure for your malicious package. Add the following code. Okay, so let's give this a shot. TryHackMe, dependency confusion. Okay, so we have to recreate this. So we will make directory and we'll call it data db connect like that, and then we'll cd into that, and in there we will. Do we just need to create each one of these? I believe. So we'll just go like touch. Or is it package name and package name there? I don't think so. I think it's package name. Well, it might be. So we might actually have to, I'm trying to remember how I did this initially. It might be data db connect and then data db connect again. Oh well, if it doesn't work, we'll fix it. Pretty simple. Recreate this folder structure for malicious package. Add the following code to your main.py. So it's just hello world. I am just going to copy and paste this. And so if we do Pluma like that. So we're just defining a main function that prints hello world. Okay, easy enough. This is simply filler code to ensure that the package does contain some code for the build. The more important part is the setup.py code. Let's take a look at what a normal setup.py file would look like. So from setup tools, import find packages, and from setup tools, import setup. Then we're defining the version right there. And then setup, we have a few things here. So here's our name, data db connect, right? That's the name of the program. The URL that we're getting it from, we have our download URL, which is at tar.gz, format version, author, Tinas Green, right? Author email, Tinas at not my real, I'm pretty sure that is his real email. Version equals a version, of course. We're pulling it from right there. Packages, find packages, include package data true, license MIT, description, dataset connection package that can be used internally to connect to data sources. In order to inject code execution, we need to ensure that the package executes code once it is installed. Fortunately, setup tools, the tool we use for building the package, has a built-in feature that allows us to hook in the post-installation step. This is usually used for legitimate purposes, such as creating shortcuts to the binaries once they are installed. However, combining this with Python's OS library, we can leverage it to gain remote code execution. Update your setup.py file with the following. Okay, we are not going to type all this out, but let's read through it all. So from setup.tools, import find packages. From setup tools, import setup. From setup tools, command install, interesting, import install, and then import OS and system. And now our version, now remember this is a race condition, so our version needs to be higher than the internal version, which that is a safe bet there. So post install command, we're defining a function called run, install run self, print hello world from installer. This proves our, So it's going to print hello world from installer. This proves our injection works. And then we have a very simple reverse shell written in Python. We're importing that, and we're going to drop our IP here. So if you've done CTFs, I'm sure you've used very similar code to get a reverse shell in Python. And then here's the setup file, and that was the same as before. So it's actually, since we have the correct setup file, the program will actually install successfully, I believe. So the user installing it won't notice anything because we are following everything. It's just during the install process, we are going to pop a shell on the victim's computer. Okay. So let's take a look at the adjustments that we made. Let's see how AmoebaMeta explains it. So we have that. We also update the version of our package. Yep. Next, we introduce a new function that will work as a post-installation hook to run a reverse shell for us. Remember to add your attack box or VPN IP, which we will do. Lastly, we hook the post-installation process in our setup configuration. Oops, I missed that right there. Post-install command. and that's this right here. So, oh, so it's going to install it all. It's going to actually install everything. Then at the end, it's going to hook in our shell, and we're going to get a shell. All right, now that's time. We created it. Let's go ahead and create this real quick. We'll just copy and paste it. Nice and easy. Copy that. Go back to our terminal, cat. Whoops, I didn't mean to do that. And we have to update the IP information, which is right here. 10.13.4.234. We'll just do the standard port 8080 that it has here. Everything else looks good to me. Let's go ahead and save that, and we'll start a listener so it's ready to go. So now we're going to build it. Now that we created the package, it's time to build it and upload it to the external Pypi repo. We can use the following command to build our package. So let's go back to doing it this way, and let's type all this stuff out for ourselves so we can learn it better. So Python 3 setup.py sdis must be like distribute. Okay. Beautiful. If I go out here. Okay, good. I think this is what it's supposed to look like. Once built, our pip package will be available under the dist folder. Whoops. Scroll back up. There it is. There's our package. It can be uploaded to the Pypi repo using Twine. So let's type this out. Upload. Oh, well, we don't need to do that because I'm already in the folder, so we can just specify the name right there. Repository URL external.pypi server.loc 8080, like that. Oh, I don't have Twine on here? Yeah, let's install it. Probably typed it wrong and now someone just hacked me. Failed to fetch. Do I need to upload? I guess I'll update my packages real quick. Shouldn't take too long. We'll rerun that command. What up, Ding10K? Are you an Nginx expert? No, I am not. Thanks for asking, though. Maybe someone in the chat is, but I am not. Can I run Nginx to 50 megabytes of RAM? How many disk? I have no idea. My dumb question, did I miss something? Why is it so easy to install on a repo? I think repos allow you to upload packages. That's just how they work. If the package isn't been named, that's how typo squatting works. I could be wrong though. That's a good question. Let's look it up. Like, what is? Let's ask ChatGPT. So create a Pypi account. If you already create a Pypi account, you need to verify your email address for you can upload packages. Create your package, build your package, and generate a distribution package. Upload your package. Verify your package. So anyone can do it, right? You just create an account and verify with an email. Of course, you can use whatever email you want. They have certain guidelines and best practices. You should review these guidelines. So eventually they'll delete it, right, when they discover it's malicious. But if we're targeting an organization, we could very easily create a Pypi account and then upload a malicious package, and then we could win the race condition. So I think it really is as easy as the room explains it to perform this attack, which is crazy. There we go. I think it's working this time for us. Download Twine and see if this works for us. Do 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 Do, 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 do. I should have like elevator music when we're installing stuff. So close. So close. We're almost there. Beautiful. See if this works now. Fingers crossed. I said ignore this. So if this is the real Pypi, right, this is where you'd enter your username and password. But anyone can make a username and password. We'll go like that. And we just uploaded the package. Amazing. Yeah. Okay. Let's keep going. You should see, we can test the code execution of our package by installing it directly ourselves. We'll just wait. You should see the print line in the output installation command and see that pip freezes when you get a reverse shell connection. Well, I guess we can try that. Should manage to get a callback. Let's go ahead and try to install it ourselves, I suppose, and see what happens. That'll be kind of fun. Make sure we don't have anything yet. Okay. So if I install this, boom. Look at that. Shelled myself. So it worked. So that's all I did, guys, is I pip installed that beast. Pip3 install. Trusted host. So the right thing to do, right, is installing it this way, and we got it. We're going to pwn them. Dependency confusion. Amazing. So let's let our listener listen for a little bit, and we should eventually get a shell. If this works, you start your listener, wait for 5 minutes. You should magically get a callback from the build server once it tries to rebuild the Docker container and installs our malicious package. Explaining what is happening in the background. So how is this actually happening? Let's take a dive into the vulnerable line in the Docker file. Run pip3 install DB connect, no cache dir, trusted hosts, internal Pypi server, extra index URL, internal Pypi server 8081 simple. Knowing that this is an internal package, the developer team added an additional Pypi repo for pip through the extra index URL. Right there. However, this does not force pip to download the package from that location. I think that's the thing that we really need to pay attention to. Rather, it is just another location where it can look for the package. Pip will therefore download the package from internal, the legitimate package, and external. So no matter what, it's going to look at the external one. So it doesn't matter what you specify as a flag. It's going to look at external. And if the package in the external one has a higher version number, you just got pwned. Since our version is higher, it will install our package instead. This is where the name dependency confusion comes from. Defenses, protecting internal dependencies is a massive security endeavor. Since we have to create, maintain, and host these dependencies ourselves, the security project is much larger than that of external dependencies. The following defense strategies should be considered for all internal dependencies. First, internal dependencies should be actively maintained. This will ensure that vulnerabilities in these dependencies do not affect multiple applications and services. 2. The hosting infrastructure of internal dependencies should be secured. The following Microsoft white paper provides the following 3 key focus areas. References 1 private feed, not multiple. This contributes to protecting against dependency confusion attacks. With our Python example, we could then use index URL argument instead of extra index URL to indicate that the package must be collected from the specified index. That makes sense. Protect your packages using controlled scopes. By controlling the scopes of dependencies, it will ensure that dependencies are locked to the applications that require them. And third, utilize client-side verification features. Controls such as sub-resource integrity or version locking will ensure that applications and services will detect when malicious code is introduced into a dependency and refuse to execute it. As an additional defense measure against dependency confusion attacks, the names of internal dependencies can be registered on external package managers without the source code to claim the name. That makes sense. This will prevent an attacker from registering a similarly named package. And look at that, we have a root shell as a result. What is the name of the attack that can be launched to create a race condition between the internal and external dependencies? Dependency confusion. What is the flag's value that is stored in the root directory on the Docker container? There's our flag. Conclusion. In this room, we discuss the security controls and misconfigurations commonly found with dependency management. This is by no means an exhaustive list of what should be considered for the security of dependencies. However, to summarize, we should be considering the following. Number one, be aware of the dependencies you use in your applications and systems. Also, be aware that these dependencies may have dependencies, right? Which will grow the list of dependencies you'll need to keep tabs on. 2, make sure to always use the latest versions of dependencies, both internal and external dependencies. More often than not, these updates to dependencies are not to introduce new features, but to fix existing issues and bugs. 3rd, it is not just the dependencies themselves that should be considered for security, but also how we configure and use our dependency managers, especially for internal dependencies. And 4, dependencies and dependency management systems should be included in the attack surface of the application or system we are developing. I understand that security should be taken seriously for dependencies and dependency management in the DevOps pipeline. Yes. And we have completed this room. Once again, a special thank you to Amoeba Man for the excellent content, the excellent room. Really, really good stuff. Well, hey guys, we've been going for, looks like an hour and 20 minutes with my cold and sore throat. And we're going to go even longer. But before we do that, let's take a 5-minute break. I'm going to get a drink of water. I'm going to chill out for 5 minutes, and I will be back. So be right back in 5 minutes.